Hello 7th graders, welcome back to my channel. Today we're going to talk about two-stage random experiments. So what we're going to look at here with this particular first example, I've got a box, got balls in it. There's 3 white balls, 2 black balls as you see, and we're going to draw 2 out of them with replacement. That is to say, maybe we draw out a white ball and we put it back in, and then we pull out a black ball. That's one possibility. Another possibility is that I get a white ball followed by another white ball. Or maybe I get a black ball followed by a white ball. Or maybe I get consecutive black balls. Okay, so as I go to display the experiment, with a branches as a set of branches we're defining here, understand again it's a 2-stage experiment. So I'm going to wind up with what amounts to 2 different layers of branches. If I was doing 3 draws, I'd have a 3rd layer. But anyway, so we start, and on that first draw, maybe we have a black ball or we have a white ball. But as we can see, they're actually not equivalent probability up here, are they? So we should get a black ball 2/5 of the time, and we should get a white ball 3/5 of the time. And all right, so then once I've drawn a white ball, I draw again after we throw the ball back in, by the way, because it does say with replacement. That's rather important when we say with replacement. You'll see why here momentarily. Because if I pull out a black ball, if I pulled out this black ball and it was, gone, if it was just gone from it, now I only have a 1 chance in 4. But that's not what's happening on this. Because I throw it back in there, I've got 2/5 probability of pulling out a black ball, 3/5 of a white, and over here it's still 2/5, and again still 3/5. So what I can do here, I can figure out these sets of probabilities here. Because I can just, it's a compound event. I will take 2/5 times 2/5. That's just multiplying the probabilities of the paths at the end of each branch. So 2/5 times 2/5. The probability of consecutive black balls is going to be 4 out of 25. The probability of a black ball followed by a white is 6 out of 25, which happens to be the same as white followed by black. And finally, the probability of both of them being white is going to be 9/25. When you go to add these together, you should see that these are going to add up to 1. Again, that's relatively simple mathematics with fractions, right? If all of the events' probabilities don't add up to 1, I have a problem. It means I'm overcounting something, or not doing my math correctly, or I'm leaving something out. Probability of a path is simply going to be the product of the probabilities of its branches. That's what you should have taken away from that. Now we're going to do it again. This time we're going to do it without replacement. So that is to say, think about that. If I draw out a black ball, remember what I said before, if a black ball comes out, there's only 4 left, and of those, only 1 of them happens to be a black ball. So that's going to be 1 out of 4, which would mean 3 out of 4 times it's going to be white, even though I drew it in purple ink there. Oh well. And of course, if I draw out a white ball, now there's 2 black and 2 whites left. Here's my better picture up here. So we're going to go ahead and multiply these probabilities here, shall we? 2/5 times 1/4 is 2/20. We'll reduce it though to 1/10. 2/5 times 3/4 is 3/10. 6/20 or 3/10. Good. This one is also 3/10, as expected. This is 3/10. Interesting how the probabilities changed. You notice when we threw the balls back in, the white followed by a white was definitely the most likely of the 4 outcomes. Here, these, the least likely one is black followed by a black. But again, if I add all these together, it's 1. So I can pretty clearly see I have covered all of my possibilities. Another way to do a 2-stage experiment, of course, is to take a ball out of 1 and then throw it into box 2 without observing it. and then we're going to draw a ball at random out of box 2. What's the probability we get a black ball now? Well, again, kind of depends on what happens with that first draw. So again, we can make a probability tree, and we'll make one side black, the other side white ball. On, again, box 1, it's 2/5 probability that it's black, 3/5 probability that it's white. Now, when I've drawn out a black ball, though, now things are different with respect to the probability of what I can draw out of box 2. Because observe, if I take a black ball out of here, throw it in, I've got 4 out of the 6. 4 out of the 6 now are actually going to be black, so that's 2/3. And only 1/3 of them now are white. But wait, what about if the first one was white? All right, well, let's get rid of that. And let's take this white ball, throw it in here. And now what's the probability of getting a black ball? As you can see, 3 out of 6, or simply 1/2. And the probability of white ball is also 1/2. And we're going to, and again, I hope we're clear on this. So this is the draw from, box number 1. This layer of the probability tree is the draw from box 2. Okay? So, all right, let's multiply, see what we get. 4/15 this branch, 2/5 times 1/3 is going to get us 2/15 on this one. 3/5 times 1/2 is 3/10, and 3/10 right here as well. Now, to answer the question, what is the probability that this ball is black? That's going to be this one. I should have done that. This probability plus this probability. So the probability of black on draw number 2, it's going to be 4/15 plus 3/10. See? So I'll have to do some fraction work here, but no worries. I passed 6th grade. We're good. 8/30 plus 9/30. So the probability of getting a black ball on that second draw must be 17/30. Okay? So enough of the draws. Let's take a look at spinners. When you're spinning a spinner, the idea is that the spinner doesn't know where it's been, so each spin is independent from the other ones. On the previous ones here, when it was getting to the fact that even though the events were independent, they were still dependent on the previous draw. Hopefully that's clear. So if event A is the same result of both spins, and the probability of each outcome is noted next to each space, what's the probability of event A that I get the same spin twice? That is to say, probability of A is going to be the probability of getting 1 and a 1 plus the probability of getting a 2 and a 2 plus the probability of a 0 and a 0. See? Now, when you start making a tree on this, I'm trying to keep these screencasts short here. Notice we could, good lordy here, I've got a, if I do this, you say, 0, 1, and 2, now I got to make a grand total of 9 more branches, right? But think about it here. Isn't it, since I only really care about 1s, 1s, 2, 2s, and 0, 0s, couldn't I just kind of make my life a little easier here by only drawing the branch that I care about, the 0 on this one, and the 1 on this one, and the 2 on this one? Isn't that going to be easier? Again, the probabilities of drawing is 0. I could see it right up here. It says 1/4. Probability of spinning, I should say, not drawing. Spinning a 1 is 1/4. And spinning 2, it's 1/2. Since the spins are independent, the probability stays the same. 1/4 times 1/4 is 1/16, though. That's your compound probability there. 1/4 times 1/4 here is 1/16. And 1/2 times 1/2 is 1/4. So when we go to add these numbers together, hopefully you look at that 1/4 and realize, hey, I can just expand this to make 4/16, and now I can just add 1 plus 1 plus 4 and get 6/16, or simply 3/8. 3/8 of the time, you should have event A happen. The same result on both spins. There's your probability. Yet another two-stage random experiment that you're asked to consider is this idea of letters in a box. So, box is selected at random, and then a letter is randomly selected from the box. So it's the probability of drawing out an E. Well, this is pretty easy on this one. You say, I know this one's 2/3. This one's got to be 1/3. This one's nothing. This is a probability of 0. It's impossible to draw out an E from this one. Now, keeping that in mind, I'm trying to figure out the probability of drawing an E. All I really have to do here is find the probability of drawing an E from here, plus drawing an E from here, plus drawing an E from here, with the idea again that each of these events is going to be happening 1/4 of the time, or each box I should say, is getting drawn out of 1/4 of the time. So, all right, so yeah, I'm just going to squeeze this in over here. So again, I got box 1, or I can draw out box 2, draw out a box 3, or draw out a box 4. And again, I want to know the probability of getting an E from here, from here, from here, and from here. Now, of course, I think we've already said box 3, 0. So really, I mean, hold on. It's 1 in 4 chance I selected box 3, but 0 chance I can draw an E out of it. So I know that probability is a 0. The rest of these, again, if each box had an equal chance, 1/4 times 2/3 is going to be 1/6. 1/4 times 1/3 is going to be 1/12. And 1/4 times 1/5 is going to be 1/20. So, add these numbers together. GCF is 60, not GCF, sorry. Lowest common denominator. 10/60 plus 5/60 plus 0 plus 3/60. It's going to give me 18/60, which of course reduces to 3/10. See? Now, if a letter is randomly selected from each of the 4 boxes and placed in some kind of order, what's the probability the following word is formed? Again, comes a point where you can just start getting a little bit efficient about this and just realize, wait a minute. So what's the probability of getting A out of the first box? 2/3 times what's the probability of T out of the second box? That's 1/3. Of an N in the third box, that's a half, and an A in the last box, that's 1/5. So 2/3 times 1/3 times a half times a fifth, it's going to equal 1/45. Probability of vane, V-A-N-E, that's 1/3. Probability of an A out of box 2 is a third. Probability of an N out of box 3 is a half. Probability of an E, and the last one is 1/5. 1/3 times a third times a half times a fifth is going to be 1/90. All right, so that's my various examples I wanted to present to you for two-stage random experiments. Feel free to look at this video again. Be sure to smash that subscribe button and press the like as well. And I will see you on Wednesday. We'll have a synchronous class, Zoom class. So watch the agenda for your link for that class. And I will see you then. Be good for your parents. Bye now.